assembly of our gearbox project. So where to start? We firstly go to start mechanical design, assembly design, and then by pressing on product name, you can change this by pressing alternate enter, and change the part number to, we start with the first assembly of our drive shaft assembly. Okay, and next we create we insert all the parts that is required for this drive shaft. Okay, so first we open the project files, and the first file will be the drive shaft. Click open, and then we need to add another items inside here, and the item should be insert existing ball bearing. We have 7040 and 1542, 7040 and 1542. So both bearings are on the same position. Alright, actually we can also rename this later on. Next we need the gear, the helical second or the third one, the 2715. Click on OK. Next we need metal sleeve. So we go here, insert metal sleeve, existing. The size is 1521. Okay, and the other components that is not available here can be actually inserted by using the library catalog browser from CATIA itself. So we go to tools, mechanical standard parts, and the parts that we need to add will be a key of ISO catalogs. So click on catalog ISO and the one that we need to have is key, this one. So we have washer, screw, pins, nuts, keys, bolts. So we need keys here, and double click on it, and the file is then given here, ISO 2491 form A. So we can recess here and look for the form A for the size, and the size that we want to have is 25 times 5 times 3 form A thin parallel key. So double click on this. So this one is here, so just click OK, and it is being put somewhere inside this assembly. Now we need to click here, click explode and apply, click OK. So we have all the parts here. Another part that is missing is the bolt, and this bolt size can be created. Now we look at how we want to do the assembly of this first part, the drive shaft assembly. So I just scroll up, so we have a clear screen like this. Then we need to rearrange this gear part should be on this side. So these holes will be symmetrical or parallel with this hole, and ball bearing, the smaller one should be here and the bigger one should be here. The smaller one should be here and the bigger one should be here, and the metal sleeve should be sitting here, and then the keyway should be sitting here, and this keyway is used to lock another gear for the next assembly. And firstly we create manipulation. We want to move this thing, so Okay, then we can create a coincident constraint by using this. When we select the axis of this gear and then the axis of this shaft, next we click on update. After that, another thing you can do is click on this vertical line axis and this also, and you have the first the first assembly of our drive shaft. Next, you want to put this thing on that surface. It should be inserted here. So basically what you have done should be correct there. You do the contact constraint with this surface and this surface. This surface, so we can create contact surface, this and this. Okay, so make sure that it is really sitting perfectly on the openings that we have created on the shaft. Okay, next we can ask the bearing to be inserted. So this one is the biggest one, should be inserted here. Can do that. Then select this one with this shaft and click that. Can move this in X direction. Okay. So which one is the biggest diameter? Yep. So next we need to do is to make sure that this surface is in contact with this shaft surface here, and click on update. Another one should be this surface here with this surface here, and click update. Last but not least will be this shaft here, sleeve here with this shaft, and the position of this sleeve should be in contact with the surface here. Okay, so we have our assembly of this drive shaft. What is yet missing is the bolt that should be inserted in these holes to connect the helical gear with the shaft. So what we can do is we can create a bolt by sketching the bolt in this assembly drawing. So what we need to do is click on drive shaft. We need to create insert, click on new part, click yes, and this part should be renamed to so you can change part 1 to bolt, part 1.1 can change to M6 bolt. Click on OK and double click on this bolt M6 this here, and double click on part body. So now we are entering the sketching new part windows or template. So now we start with the sketching of the bolt. We create one plane. It should be on YZ plane, I think. Yep. Okay, so in this YZ plane I create one bolt with the simple sketch of bolt like this. Yeah, create the first hit cap, then create this shaft cylinder. And then we rearrange the dimension. So we must have a length of 28, and the distance between these two would be 26, and so 26, 8, so this is only 2 millimeter. Something. Next will be the length here should be 6 in diameter, so this tool should be 4 only, and we don't have a center line, so I create one center line. One center line, and I want these two vertical lines to be symmetrical with this thing, with this center line. Same goes for these two lines. Okay, now we have created this bolt sketch. What we need to do now is finish the sketch. We have these two radius of 0.5. Same goes for the second one, but I don't need to create that. And this one will be created by using solid chamfering. So the same goes for the neck here. So next, what we need to create is I need to trim this, because later on, after I exit the sketch, I will revolve the sketch around this center line, and we get the bolt by revolution. So just delete all these lines. Okay, and this line too. So exit the sketch. I go to shaft definition, so 360 degree. Sketch axis is already given. You can click OK. So we have the bolt, and we have to do the trimming, or do the treatment on the surface here. Here should have a edge fillet of 0.5. Yes, and then the line down here should be chamfered 0.5 and 45 degree. So we like to look at the shaft here. We have the 0.5, the diameter, sorry, the chamfer, and this is 6 and this is 4, 26, 28, 0.5, 0.5. Okay, so we have the bolt finish being construct. So we can also change the color if we want to assign a material on this. We can do that also. Go to metal, and it should be iron or steel. So the metal, the bolt material is steel. Okay, so now we need to have this back in pressure assembly. So what we want to do next is select this and select this. So we have that material. Okay, so we want to get this right. Okay. Right, then we need to make sure that I think the color is too striking. Black is not good. Go back to bolt part body, And graphic, I think change to a little bit yep less uh, less striking. And can connect this bolt into the hole. So firstly we create coincident constraint with this vertical axis of the bolt and then the vertical axis of the hole. So we click on update, we get that. Next we can create an offset between this surface and the middle line of this shaft. Where is it? Yep. And since we have length of 26.5 26, you can put 12.5 as our suitable diameter for the bolt to be connected and offset with the holes there. Or we can also do something like we hide this and we add the, so this one is sleeve drive shaft, we hide this and we create contact constraint between the surface and enable the drive shaft, disable not disable, and hide the bolt and click the surface, and then we can click OK. So we can just delete this as our redundant constraint. So we have already 3 types of constraint defined. So we can delete one that is redundant. So in this case we can delete one of it. So if I want to use this constraint, I can just delete the offset here and show back all the elements that is being created just now. Okay, so we have the drive assembly finished, and we can proceed with the second assembly. Okay, thank you for watching.